Scientific notation is a way to represent really big or really small numbers. All right, so this first one here, 2.3 times 10 to the 6th power. When you times a number by 10, you are adding a 0 to the end, or you are moving the decimal to the right one time. So we can take 2.3 and we're going to move that decimal to the right 6 times. So if we times it by 10, we'd have 23. And if we times it by 10 again, we'd have 230. So we've moved it 1, 2, 3, 4, 5, 6 times. And we're going to fill then all of these in with zeros. And so this would represent the number 2,300,000. All right, let's try this next one. So 1.46 times 10 to the 8th. So we're going to move that decimal 8 times to the right or towards the positive direction. 1, 2, 3, 4, 5, 6, 7, 8. So I have to add on 6 more zeros. So this one represents 146 million. All right, so this next one has a negative exponent. That means we're going to move the decimal to the negative direction or to the left. So I'm going to write 3.04 over here. And we're going to take our decimal and go 1, 2, 3, 4, 5, 6. And it's going to go right here instead. I'm going to fill these all in with zeros. And I'm also going to put a 0 in front of the decimal because we should always have a digit in front of the decimal. And then this decimal we don't need anymore. Okay, so that's a super itty bitty number. All right, so for this next one, if we have 5 and 7/10, and we're timesing it by 10 to the power of negative 10, we're going to move the decimal to the left 10 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're going to make all of these zeros. And then to be polite, we'll put a 0 in front of that decimal because 0 is the same as nothing. Now let's try going in reverse. We have the really large or really small numbers, and we're going to write them in scientific notation. All right, so what we're going to do is we want one digit that's not a 0, followed by any extra significant numbers which are not 0. So this one would be 3, then the decimal, then the 7. Okay, if by chance that 7 was a 0, it would just be the number 3. Okay, then times 10. And then the exponent is how many times you would have to move that decimal from here all the way to the end. I'm actually going to start at the end and I'm going to go backwards because I like those commas. So here's 3, 6, 9, and then 10 to get it to that other side of the 7. So that exponent would be 10. All right, so for the next one, 4.86. So I'm only using those numbers that are not zeros. So we need the decimal to go from here, all the way over here. I'm going to actually start counting on the right though, so it's easier to skip count by 3s. 3, 6, 9, 12, 13, 14. So I would have to move that decimal 14 times to the right. All right, next one here. All right, so this one, all I see is a 4. So it's just going to be a 4. I don't need a decimal for that one. Times 10. Now my exponent is telling me how many times I'm going to move the decimal from right here after the 4 all the way over here to where it should be. All right, so this one, 1, 2, 3, 4, 5, 6, 7, 8, 9. I'd have to move it 9 times, and I'd have to move it back to make that super itty bitty number. All right, so for the next one, 2.7 times 10. And I have to figure out how I get my decimal from right here after the 2 all the way over here to that decimal. This one I'll start counting at the stars so we can see that there's more than one way to get it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So that exponent would be negative 13.